In the history of science, often the most interesting problems emerge at the interface between different disciplines. And our work falls very much in this category. The study represents an attempt to bridge between epidemiological studies in people and biological studies in experimental animals, particularly in mice.
What you find in the human population, that there is a unidirectional order in which, for instance, 97% of cocaine users have smoked before they started using cocaine. And the beauty of the animal experiments is that you can reverse the order of exposure and have an opportunity of understanding what the underlying mechanisms are that could explain the unidirectional effect.
If you take nicotine acutely just once, its effects are very short-lasting. But if you start to take it repeatedly, like other drugs of abuse, it starts to produce changes in the brain, which we call neuroplastic changes, that will last much longer after the nicotine had been discontinued. For example, in this very elegant work of Dr. Candels and his collaborators, they showed that repeated administration of nicotine produces changes that actually prime the brain to feel the rewarding effects of cocaine more intensely.
What we did was we treated mice with nicotine for 7 days, and then we gave them cocaine. So we designed a sequential treatment paradigm. And then we did also the opposite. We treated mice with 7 days of cocaine and then gave them nicotine. Typically what happens when a mouse is injected with cocaine, it starts to run around a lot, and then if it's given cocaine again and again for the next several days, it would run around even more and more. But then when you give nicotine first for 7 days and then you give cocaine, the mouse would run around a lot more than if it just got cocaine by itself. So somehow nicotine was able to sensitize the mouse to cocaine. And then we looked in electrophysiology, we measured electrical currents in the rewarding area in the brain. And typically cocaine has a very specific electrical current in the brain in the place that's called the nucleus accumbens. But then if we treat with nicotine first, we see that nicotine would enhance the effect of cocaine in electrophysiology. So then we moved on to look at gene expression, and we concentrated on the FOSB gene, which has been called a molecular switch for addiction. And what we saw was that if you treat with cocaine, you see an increase in FOSB. But if you treat with nicotine and then you give cocaine, you see a great enhancement of FOSB expression. So that was very, very important to see that it also on the gene level, you see a great enhancement of the effect of nicotine on cocaine.
You have an anatomically different brain as a result of addiction. There's growth of certain processes, retraction of others, so it's anatomically different.
These findings really reiterate how important it is to never start smoking to begin with. But it also gives you an idea that stopping smoking is also very important.
These are things that we have to face as we recognize that cigarette smoking, though the prevention efforts have been very effective on decreasing it, we still have a massive problem with respect of number of people that smoke and die, or if they don't die, suffer from its consequences. It's gigantic. And every day we have new people starting to smoke. And that needs not be. There was no cigarette smoking addiction at the beginning of the 20th century, none.
So stopping nicotine usage is doubly important. And it has tremendous public health significance.